And fortunately today we have Dr. Kevin Crowley and from the University of Pittsburgh, and he's a professor of learning science and policy at the University of Pittsburgh, and also senior scientist at ARDC. He directs the University of Pittsburgh Center for Learning in out-of-school learning environments called UpClose. And Kevin has been nationwide, actually well-respected scholar in science education, and especially in informal science learning. And it's very fortunate for us to have him with us today, and we have the opportunity to listen to his talk and then learn more what he does. And hopefully you also may have some questions, and you can feel free to ask us when I talk. Okay, let's welcome Dr. Kevin.
Well, thanks for the invitation to talk. It's a pleasure to be here. When do I have to stop?
About 1 hour.
About an hour? Okay. So these days, I like starting my talks with this picture here. This is the STEM pipeline. This is an official policy picture. It comes from an official policy document published by the NCES. And what it shows is, I think, how we tend to conceptualize STEM education at least in North America. So what it shows is in 2005, there were 4 million eighth graders in the United States. And of this 4 million, about 3 million will graduate from high school. So we already lose about 1 million from 8th grade to graduation of high school. But of that 3 million, only about 2 million will actually plan to attend college. And of the 2 million who'd like to go, 1.3 are actually college ready and enroll in college. And of that 1.3, we started with 4, we're down to 1.3. About 300,000 will major in STEM. And then if you go over here, about 166,000 of those will actually graduate in STEM. And so you start with everyone who's in 8th grade, and you end up with this little drip, drip, drip into these STEM graduates here at the end. And then if you follow this 166,000 for another 5 years and asked who actually is working in a STEM career, this number drops by about half. So we get about 80,000 STEM workers from these 166,000 STEM careers. And so it's not new to you. You guys have all heard about pipelines and pipelines that are leaking, which is how this one is. And I think that way of thinking about STEM education introduces some really deep, persistent problems. One of them is right here in this critical part of the pipeway from high school through to college. There's all sorts of pressure points, all sorts of moments when things happen for kids that we don't quite understand. So the transition from high school to college, or what happens early in a college major in a STEM career, or what makes someone want to persist and finish, are all points where we're hoping that what we do in K-12 education prepares someone to be resilient and successful when they get that far in the pipeline. But we really don't understand much about what we can do for people early in their life that helps them here. And then I think the biggest problem with the STEM pipeline is 98% of the population just leaks out of it and goes down this little drain, which they've helpfully drawn in this policy picture. So 98% of the people that we teach in science education are not actually even an object of interest for us, because our politics and our pedagogy is all about creating that small 2% who eventually end up with STEM careers. And what are we thinking about with these people? What are we doing for them? How do we conceptualize science education for people who either can't finish the STEM pipeline or decide that's not what they want to spend their lives doing? So recently people have been using another metaphor to talk about science education. Oh wait, I got more pipeline, sorry. My favorite part of the pipeline. My favorite part of the pipeline is we tend to think about it from high school to college and ignore this, K through 8 schooling. There's an awful lot that kids do that prepares them for this moment. And particularly in my work, there's something else we ignore, which is the entire rest of childhood, which is what surrounds kids in K through 8 schooling, which prepares them for this lifelong engagement with STEM. So there's another metaphor people have begun talking about, and it comes from a National Research Council diagram. Are folks familiar with this? Raise your hand if you've seen this diagram. A couple people? Okay. So what this is here in orange in the middle is the percentage of your life that you spend in formal education settings. So here, when you're in 1st and 12th grade, you spend about 19% of your waking hours in school. And as you progress, it becomes a smaller and smaller amount. Once you're working, you occasionally receive some training. But most of what you learn, most of what you experience happens in out-of-school settings. So rather than just concentrating on the series of experiences in school that prepare you to learn STEM, people have now begun talking a lot about a broader educational ecology that surrounds us throughout our life. So in reality, kids bump into something like science all the time in out-of-school settings. And what they learn and what they will eventually bring into a STEM, a pathway towards a STEM career, doesn't just come from school, it comes from this broader set of out-of-school experiences. So when you think about learning that way, it's not about how to design a pipeline that efficiently and with minimum loss brings people from the beginning of their educational lives to this STEM career that we value economically and societally. You begin to think about education as how are we providing rich ecologies that support the momentum to learn science throughout someone's life and provide resources that help them navigate a diverse set of pathways to science. So it's not a pipeline that goes from point A to point B. It's an entire responsibility we have to help people find a path towards science. And I think there are multiple paths that are out there. There are multiple experiences that people use to learn STEM. And my work is all about trying to figure out what these words mean, what momentum might mean, what the resources are, and how to design them effectively, and how to think about creating pathways that help people move over time and place and learn things like STEM. So the work that I do, I'll just briefly say, I run the center Yeping mentioned called Up Close. And the way we work is in deep partnership with educational organizations. Many of them here in Pittsburgh. They've worked for 15 years with the Children's Museum of Pittsburgh, about 10 years with our Museum of Natural History. But we also have worked with many other museums, community organizations, media organizations in town. And it's really doing research right at the boundary of research and practice. So my graduate students sit on design teams, help design programs, and conduct their dissertation research out in these organizations in town. And we also have been doing some work nationally. So the talk is in 3 parts. The first part is about this idea of momentum. How does someone get momentum to be interested in and pursue science throughout their lives? So the work I'm going to talk about is part of a larger group called the Activation Lab that we have at University of Pittsburgh, University of Berkeley, SRI International. Is funded by the Gordon and Betty Moore Foundation. And very briefly, what we think about this idea of momentum, this is somebody's life right here, from about the age 5 to about the time they're an adult. And early on, there's some collection of learning experiences that characterize people's lives. Our hypothesis is that there's a critical moment where kids become activated towards science. So rather than just kind of learning about it and moving through school, there's a moment when they can become interested, they can become motivated, they can become connected to science. And we think that needs to occur by about age 11. And at that time, at about the age 11, if kids are activated towards science, when they get into increasingly challenging science experiences in high school and college, where it becomes more and more about gatekeeping and more about finding people who fit comfortably in the pipeline, they'll be resilient, they'll be motivated, they'll want to struggle and get on to outcomes that look like STEM career outcomes for broader scientific literacy. And so it's not a critical period for activation, but it's a moment before they hit science in high school where kids, we think, can be at their most interested and most open towards out-of-school learning experiences. The Activation Lab is trying to define what that is. And as a first step towards doing that, I'll just say first that we define science learning activation as a state, which is a composition of disposition, skills, and knowledge. So it's not just knowledge, it's disposition, skills, and knowledge that enable you to be successful the next time that you encounter science. So the hypothesis is all science education ought to make you activated, which means you've got the disposition, skills, and knowledge that the next time you encounter science, in or out of school, you have the capacity to be successful. And the more successful you are, the more you ramp up your activation and learn that science is something that you're good at. And I won't talk at all about what's in this black box of activation in this talk. I will say that fascination, values, competency, belief, and scientific sense-making are some of our hypotheses about the underlying attributes here. You can go on to activationlab.org and read a lot more about the construct and the measurement. I'm not a measurement person, but there are people in the lab who do assessments of activation. Okay, what I want to talk about is life histories that we did with scientists and science educators. So we were asking people who made it to the end of their, well, not the end of their lives, they're working in science. And we wondered, what was it that got you activated towards science? This is a picture of a life history calendar, which was one of the data collection tools we used. We had 100 scientists, science educators, and also a sample of artists that we collected, where we took them through multiple periods in their lives. We said, okay, so in grade school, who are the people that you talked to science about? Were there any experiences that you think were really pivotal? What did you do in school? And we took them through grade school, middle school, high school, college, their professional life. And these interviews lasted between an hour and 2 hours. And from that, we construct these narrative life histories to try to identify the moment when they became really passionate about science and what led to that. So here's some of our top level findings. 86% of the people who were working in science did in fact report that they had a strong childhood interest in science by the time they were 11. So this hypothesis about people get focused early on in science turns out to be true for most of the people that we interviewed. Only 16% of them, though, said that they knew they wanted to work as a scientist when they grew up. So this interest, this fascination, this activation was more around the topics, more around the stuff of science than a potential career path in science. 28% report that that positive experience was linked in meaningful ways to formal education, and 55% report that that activation towards science grew from informal experiences. So this high-level data suggests, yes, science is something that people are learning about in out-of-school settings, which is not much of a fight. You probably knew that anyway. And that the place where we might want to focus our attention is what happens in out-of-school settings. Remember, these are kids who are finishing middle school. There's not a lot of science in the North American middle school curriculum. Most of what they know about, they learn in out-of-school settings. So we also saw that kids, or people, when they talked about their childhood, they related a number of events to us. This is the average number of events that were related that we detected being about this phenomenon of activation. And in childhood, people are engaged in a lot of events that activate. In middle school, it drops off a little bit. And then in high school, it begins increasing. And interestingly, we saw that also people describe deactivation events, things that made them not want to pursue science, that made them less motivated and attached. And that showed the same kind of characteristic dip, where in elementary school, science was more present in their lives. In middle school, it was less of an interest, and then it moved down to in high school. And these are people who made it through the pipeline and are working in science. You can imagine these graphs for people who didn't make it through the pipeline. I would think the deactivation would be quite higher. And in the question time, we can talk about this middle school dip. I think in a lot of areas we see less interest in STEM in middle school as kids get engaged in other things and as they first get formal science instruction. But we can get back to that question period if you want. What I really want to talk about is the qualitative analysis of what early activation looks like. So when we read through their stories, we detected a couple of different areas around which interest in science seems to coalesce. And one of them was a passion for knowledge. So there are some kids for whom the facts of dinosaurs, the taxonomy of dinosaurs and who they ate and where they lived, becomes a consuming passion. That is true. There's also kids for whom bugs or for whom technology becomes the thing they care most about. And what we heard in these stories were people who were really discovering for the first time the power of systematic knowledge. They knew that when they, for instance, knew all about dinosaurs, they were smarter on that topic than their parents. So they began to see how knowledge was a key towards power. We also encountered some people for whom nature was the early connection to science. So these stories of all, these are old photographs because that's when our subjects grew up. People who were out on farms, and we know this is farms, there's a chicken there. People who were in nature, led experiences in nature, and people who went on family camping trips all had the opportunity to form an early connection to science. And at the time, they didn't really see it as science. They saw it as nature, a connection to it for being outdoors. Another group of people talked about a passion for tinkering. These were the kind of classic mad scientist types. They took things apart in the basement. There were also a lot of people in our sample who worked in shops with their fathers. Half of our sample was blue-collar, non-college educated. And a lot of people talked about, particularly engineers, talked about their earliest connection towards engineering coming from shop work and skillful tools. Some people talked about math, puzzles, and problem solving. So elegance of mathematics, the ability to use numbers to describe phenomenon, and particularly logic puzzles were things that turned out on some people in our sample early on. And then finally, there were some for whom medicine or veterinary care in animals was the earliest connection to science. So these 5 passions, none of them looks or sounds like something that the STEM pipeline is preparing kids for the STEM pipeline. All of these experiences have deep connections outside of classrooms, and only for a few kids did these really seem to be careers. The kids in this category, by the way, thought they might be doctors or veterinarians, accounted for a number of the people who were career-oriented in our sample. So how are you going to get to a broader group of kids and give them the opportunity to be activated around science this way? If it comes from experiences in the home or from informal settings, and it only rarely occurs in the context of schooling, we need an infrastructure to open up early science experiences to more diverse groups of people. And that's really what the second part of my talk is about. It's about what are the social, material, and cultural resources that support successful engagement in out-of-school learning. I mentioned I do a lot of work on thinking about museums as learning environments, and a lot of thinking about how they could be places where more easily people engage in science, technology learning. They're classically informal learning environments, so I think we can learn a lot about informal learning in general by understanding museums. They highlight the social dynamics of learning, the role of learning talk, and the role of parents in helping kids get connected to science. They're cultural organizations. They themselves are scientific organizations with a mission towards science many times. And they're also places that depend on attracting paying visitors for the most part. So they love to experiment with new approaches that will bring visitors in and give them a better experience. So they're wonderful partners for designing experiences to test our hypotheses. So I'll talk about one example study where we tried to recreate a botanical garden experience as a more powerful science learning experience. The questions of the study were, how do families learn to observe scientifically in museums? And can we encourage more family learning talk about observation in museums? So the study takes on the problem of pollination. So here are some bees that are flying around pollinating these flowers. And what we were interested in is when a family wanders through a botanical garden, could we get them to focus on pollination events in ways that were more scientific and more supportive of learning? And we decided to do it by trying to change the way that families talk when they visit the botanical garden. So there's a group of, the intervention was around these elaborative conversation strategies. And basically, it's a very simple technique. It came out of children's memory research, where you simply train people to ask a bunch of what questions. So you look at what your child is looking at and you say, well, what are you looking at? Why do you think that's happening? Where do you think that's going on? So open questions that are intended to get the conversation going while you're looking at the pollination. So in the study that we ran, we had it was a 2x2 design. We had some parents with higher biology knowledge. We had some parents with lower biology knowledge. Half the parents were trained to do this elaborative conversation strategy, and half were not trained to do this strategy. And the training was extraordinarily simple. We wanted it to be something museums could actually use. So we made a pamphlet, a little fold-out pamphlet, and a short video that parents would watch before they got to the botanical garden. And then when they got there, we would simply check to see, had you done that stuff, and do you know what this strategy is? So this is a pretty low footprint intervention. It would take people about a half hour total to learn strategy. And what we asked all families to do, we gave them a pre-test on how much they knew about pollination. We had them do unguided observation in the children's garden in September and October, which is when pollination is really hot in Pittsburgh. And then we gave them a post-test on their pollination knowledge. And we sent them into the garden with just the prompt. You can learn a lot about bugs and plants by looking for and talking about pollination together. So we went off into the garden, and what we found, we were interested in the effect of the child's knowledge and the parent's prior knowledge, the impact of parent training on the use of these elaborative strategies. And so I'm going to show you a path diagram that was constructed from a series of regressions. And what we found was the parent training was successful in increasing the number of elaborative conversational strategies that were used in the garden. And the untrained parents also use them as kind of a natural part of discourse to do it. But when you're trained, you increase the frequency with which you use these strategies. And then we were curious, if you use these strategies, did you in fact begin to learn about pollination? So we looked specifically for talk in the garden. These families had been microphoned and they had been videotaped. And we did a discourse analysis of what we did. And what we found was the extent to which you engaged in talk about pollination, which here we call disciplinary talk, was a direct result of prior knowledge and parent prior knowledge, which you'd expect people you more likely to talk about. But we also found that the elaborative strategies, even though they were just a general conversational strategy, they weren't at all about pollination, resulted in more disciplinary talk while families were in the garden. And then finally, when we did a post-test on child knowledge, we found that prior knowledge obviously predicted post-test knowledge quite a bit, but there was an independent contribution of disciplinary talk to prior knowledge. So the whole system was, I think, a successful test of the fact that you could, with pretty simple prompting, get parents to engage in a different kind of discourse, which increased the amount of learning talk, which then had an effect on kids learning more about pollination from visiting the garden. And a lot lot of what I think my work is on, the field is focusing on right now, is within learning environments, trying to find these kind of gentle ways that you can lean over and nudge a learner to engage in more productive kinds of engagement activity in informal settings. You never want to turn it into school. You never want to make it about teaching, because that's not why they've come there. And that's not the real opportunity when you're standing in front of a bunch of live bees and butterflies. It's not to go through a detailed account of pollination. It's to learn to observe pollination events in nature and start making sense of those phenomena. But it makes it difficult when you're in a free choice environment like that to think about how we're going to design for improved learning. So there's a lot of work right now on simple strategies, simple signage, different kinds of interactives that help people engage more meaningfully in STEM learning. So when they talked in disciplinary talk about pollination, here's what it sounds like. And this gets to my point about it not really being school. When you see learning in these environments, it's not what you're used to seeing if you mostly look in classrooms. So some of the things that we saw, which we think were pretty valuable learning events, were comments like this. So butterflies have really long tongues to get the nectar out of those flowers. See how that bee is crawling around inside that flower and getting pollen on his legs? These are different comments, not a single conversation. See, he gets pollen on his tummy. Look at how fast that bee is getting pollen. It doesn't stop. See, butterflies land on these flat flowers with their long ears and get the nectar with their long tongues. So what the parent is doing is they're beginning to mark the event in terms of what are the important features you should attend to, what are some potential precursors and antecedents in this causal or this process chain that they're looking at here. Looks like bees have already been here. The pollen looks all dried up. This one is already made into seeds. He's sipping the nectar. And then they go back to the hive and make honey. So this collection of comments kind of tells you all about pollination, but in the context of the observations. And when you measure knowledge at the end of a museum visit, you're not looking for all of this from any one kid. What you're looking for is the family has begun to kind of rehearse themselves as people who know how to learn about science. They know how to talk about it. They're used to pointing out important features in the environment, and they're used to collaborating on what the experience will look like. So I'll talk about some newer work just very briefly. In the Natural History Museum, we've been trying to tinker at a larger level at how you might redesign a space to encourage that type of close parent-child learning and observation. So this space is a prototype of a space called Exploration Base Camp. And this Natural History Museum in Pittsburgh is a typical natural history museum. It has fantastic collections, most of which are behind glass, untouchable, unapproachable. So what are you going to do with young children in a natural history museum? Because they can't do anything other than run around and kind of look at things. This museum had an educational loan collection down in the basement. I don't know if you can see it well from the back, but these are little toolboxes, just toolboxes from the Home Depot. And they're filled with objects, activities, books. And for years, this collection was loaned out to teachers in Pittsburgh who wanted to do a classroom activity about natural history. But it was only being used by a small number of teachers each year. So when we started working with the museum on this, we just said, hey, what happens if we just put this whole bunch of boxes up on the floor and let people have at it? And so that was the idea of Explanation Base Camp. We've just got to... That can't... Oh, that's my fault. Sorry. That's Box helpfully updating my files. So, we brought all the boxes up. We put them on cheap shelves. We found these things in the basement. They're little benches that had been used in a previous exhibit. We did buy, for this prototype, a square of carpet from IKEA and 3 blue beanbags. So for the total cost of about $150, we put up this space. So I'll show you a little video of a typical Saturday afternoon in Exploration Base Camp. What I want you to do is just get a sense of the traffic patterns here, what people look like they're doing. Kids running to the boxes, picking them off the shelves, bringing them back to their parents. You'll begin to see these beanbags moving all over the floor. People setting up places where they can go and bring things back and talk about them as groups. People observing what other folks are doing. Boxes are left open, they discover them by accident. Lots of intergenerational interaction. The space is serving really well to kind of bring people back together. This intense crash pad where the beanbags are in here and kids are in here. And families in a natural sense, they're used to kind of looking at each thing for a few seconds and moving on. Here people are spending, a half hour or more exploring this set of boxes. And what this space allows us to do, the reason we call it Exploration Base Camp is it allows us to start imagining places where people will come and rest and explore that we could use to give them tools, to give them ways of looking at the rest of the museum that would make that experience more valuable for them. And what I love about this example is it's not about the materials being so fantastic. Most of what's in the boxes isn't real. Most of what's in the boxes are cheap and replaceable things, or else they wouldn't be in the boxes in the first place. But what we were able to do is create within this broader museum experience a place where we could start getting things like observation and conversation, start giving it a platform in which we could work on. And I think this is another really important point about informal spaces. It's as much about getting this interaction and getting people to feel good about this interaction as it is thinking about knowledge processor skills. At the Children's Museum of Pittsburgh, we've also been doing some work designing their new make shop, which is an area where families can come and make things together. There's all sorts of materials, all sorts of tools. There's plans from other projects up on the wall. And the entire space is designed to encourage adults and children to work together on things like soldering. This museum is devoted to the philosophy, play with real stuff. Don't need fake stuff on the floor. So if they're going to have a make shop, it's going to be real knives, real saws, real hammers, real soldering irons, and kids are going to be able to kind of access that in the same way, I think, as in the earlier examples, kids who got turned on to science were accessing real tools down perhaps in their father's workshop. And in this make shop experience, we think a lot about these interactions that parents and children are having. And just very briefly, we're interested in outcomes such as helping people question and explore, tinker, test, and iterate, hacking and repurposing materials and tools, seeking out social resources and material resources to help them, combining and complexifying their plans, customizing technology, and learning how to talk about and share their work with a broader community. And I should say Lisa Brahms, my graduate student, was my graduate student, is leading this development of this make shop. Okay, so that's designing moments of learning. And the last part of my talk, I'm now going to talk about catalysts. So far I've talked to you about some work I've done around what gives people momentum towards science, and what each of those experiences, if you think back to that diagram I showed, each of those little dots needs to look like. So then how do we put it all together to help support an effective in and out of school STEM instruction? So in essence, from all of those experiences that present themselves, each of us has a unique path that we found through life in and out of school to take us to STEM. And I think a lot of times, certainly in formal education, I think a lot of times in informal education, we overlook this part of the equation. People who, like, if you went across to whatever science building is nearest to us and asked the scientists there, how'd you get into science? They'll all tell a narrative about how they made good use of in and out of school experiences. And it's true they did. And when you stand here the way we did in those retrospective studies and look back, it all makes perfect sense. There were some accidental events, there were some serendipitous things that happened, but in the end, the pathway made sense. The problem is, we think about those accidental pathways as if they were true pathways that other people could follow as well. When you stand here in the perspective of a kid and you look out at all those experiences, you know, it's like being a billiard ball or something. You're bouncing from place to place and you never even quite know where you're going. You don't know if you're on a pathway to science. You don't know what your next experience will be. We leave it to chance. We leave it to kids and parents to find their own way through the educational ecology. And it's producing enough STEM people right now. We have actually not a shortage of scientists, but it's not very equitable, because what we're doing is we're allowing people who have more access to resources, more knowledge about resources, and more knowledge about potential pathways to find their way through this maze, and we're kind of ignoring other people who may not know what a pathway looks like. So in Pittsburgh, we've been working very intentionally to try to design pathways through our educational ecology. This is Pittsburgh. These are our 3 rivers right here. And funded by the Grable Foundation in Pittsburgh, we've been doing work with 4 groups of organizations on just the first part of the pathway, which is start thinking about your work, not just as people showing up and receiving what you can give them, but as part of this longer chain of events in somebody's life. So we're hoping a project like this, and for pathways to form, organizations have to begin developing a shared aspiration for the city's youth. We all have to, in Pittsburgh, be talking about the same set of outcomes for our kids. We need a research and practice infrastructure that helps us garden in this educational ecology. We need to tune the goals of experiences so that they lead to productive pathways. We're taking a bottom-up approach, finding what is strong and good and working in the city and trying to connect it. And then we're also, through this measurement work of activation, poised to add to it a regional assessment of science activation that we would be able to give to kids across the city, that we'd be able to detect if certain pathways are working or not. That's a long-range vision. What I'm going to talk to you about now is over the last year, where we've taken the first step. We took the first step by funding a group of design fellows in Pittsburgh. There were 4 of them. We see them as dual citizens who cross research and practice. They spend half their time at the university and half their time out in informal education organizations. And they work with the organizations to focus on where these kids are coming from when they come to us, and where the next step might be for them. They collected data, and we're helping to use data for decision making. And we thought of them as pollinators in the city, people who were moving around, talking about activation, talking about STEM learning, talking about pathways to get that conversation going more broadly in the community. So I'll give you 2 examples of the work we did. Marty Lowe, who was a design fellow at Assemble. Assemble is a community drop-in space for arts and technology. It's in a distressed neighborhood in Pittsburgh. Kids can drop in after school, or they can come to organize summer programs, and they can do making experiences. They can work with robotics, like creative robotics around Arduino and things like that. So what they worked on at Assemble, the design fellow Marty and the Assemble people, was what she's taken to calling the pamphlet problem. So here's the pamphlet problem. You are a parent. You brought your kids to an experience. And hey, they seem to like it. You know, they're doing this stuff with these robots, and they seem to like it. So what are you going to do? You walk around, and most organizations have conveniently provided you with a set of helpful pamphlets about related experience in Pittsburgh, or not. This is actually all that we mostly give our parents in most cities about what you could do next with your child, what you could do with your child, and they seem to like technology. It's a bunch of disconnected sets of basically marketing information that organizations have created kind of independent of each other. And so what the study was she had parents sit down and read a stack of pamphlets and then ask them, so what does that look like? What do you think your kids would learn there? Who's this experience for? Who would be comfortable in this kind of program? And what she's finding, she's analyzing the data now. First of all, it's really hard to make sense of the opportunities for your child if they like robotics, if you're just looking at pamphlets. That part won't surprise you at all. The other thing is she's finding pamphlets often unintentionally are signaling to audiences that some programs are or are not for them. So some of the pamphlets make a big deal about this is a program with Scratch, which is a computer language for kids developed at MIT. And there are certain parents in Pittsburgh for whom Scratch, they know what that is, they've heard of it, they've read about it in the paper. And MIT, yeah, I know what MIT is, I want my kid to go there someday. So that pamphlet for them is like, yeah, my kids are going to this program. There are other parents in Pittsburgh who've never heard of Scratch, who if they've heard of MIT don't aspire to send their kids there. They say, yeah, this is probably not going to be for my kid. They're not going to feel comfortable. It's going to be those kids from the East End who come to this program. East End is where most of the university faculty live in Pittsburgh. There are other parents who would prefer to have broad experiences for their children. There are other parents who don't want the kids to be bored. So they're looking for the thing that's the next level up. So there's a set of dimensions that we need to communicate to parents when we talk to them about programs that help the parents see the pathway and know whether or not the next experience is appropriate for their kids. So Marty's working with Assemble to begin a conversation in town about how we could present ourselves to parents differently so that it began to look, from 30,000 feet, it began to look more like there was somewhere to go with it if you liked what you saw in this program. Another collaboration is a graduate student named Stacy Kehoe, who's working with the Pittsburgh Parks Conservancy and a group of environmental-related education organizations in Pittsburgh. And she's working on a similar problem, except around teachers. So how is it that teachers know what the set of environmental experiences are for kids? Oh, and I don't have another slide for this one, so I'll just tell you. So what they're doing now is there's some programs that do field trips to local parks, and they're trying to connect a bunch of the environmental education organizations to those field trips in a way that the field trips develop the skills kids would need to collect data when they could go to more advanced experiences where people are doing like water quality monitoring or air quality monitoring or bio-blitz activities where they're doing bio scans in various regions of Pittsburgh. So using the field trips as kind of basic training and then connecting the kids to more advanced environmental opportunities. And again, that kind of pathway, when she looked at the ecology in Pittsburgh, what she saw is basically we do a lot of introductory experiences and we don't do a lot of intermediate or advanced experiences. So every organization is kind of over-producing the first brush that you'd have with nature and aren't provided with the deeper, extended experiences that people need to have an actual pathway. So the thing about pathways is, I think when you start intentionally designing it, there can't be an infinite number of pathways. We can't just expect people to find it. So I think there's got to be more like 5 or 10 pathways that a city the size of Pittsburgh would be able to invest in, be able to figure out how we could support these sensibly, how we could connect organizations. And so that requires making choices about what we believe in Pittsburgh, what we want for our kids, and what we're particularly good at. Parents, children, and educators need tools to navigate pathways. There need to be on-ramps to pathways everywhere, in every neighborhood all over the city. But then there also have to be these middle-level and advanced experiences so kids can go deep on a pathway. And finally, it's really hard for organizations to think about pathways. They're used to thinking about each other as competitors for audiences, for foundation dollars, and sending an audience that I've got right now with my program to you so you can do an that's a really great thing for an organization to want to do because they're not seeing those kids. They're not getting that foundation money to run that program. So it really is kind of changing the conversation about how we think about the infrastructure from a set of kind of frenemies to a bunch of people who see themselves as having a common destiny. So I'll end my talk with these thoughts about this whole way of moving towards from a pipeline to ecosystems view. I think it causes us in informal learning and STEM education more generally to emphasize the importance of multiple pathways and focus us on the diversity, relevance, and really the hyper-local nature of out-of-school experiences. How are we using what's right here in this community in an intelligent way? It creates a problem for us in how do we measure whether we're creating healthy ecosystems. We know how to do program evaluation, we know how to do individual assessment, but how can we look at an infrastructure and tell whether we've done a good job investing in that infrastructure? And then how do we intervene in this infrastructure that's really more at the ecosystem level? And I just gave you an example in my bed, which is pathways in intervention. And then finally, how do we invest in healthy ecosystems? So in education, most of the levers we have that are easy to operate are top-down levers. And we want them to be scalable. We want whatever we do in one educational situation to be useful in another, particularly when it's schools, but also we can talk about more that way. The ecosystem idea, it's not just that we need more money. We need to really think differently about learning because it's a lifelong, life-wide experience that you're doing in all different sorts of places. I'm curious to see us think more about how this ecosystem view can really transform what we think about as an intervention in learning and get us to be much more directly connected with this idea of directly supporting STEM pathways throughout somebody's life.